Now I'm going to bring another shot in here to see. We got 2 shots, so projects, let's do that. So for this one, we're going to go ahead and do the Nuke setup. That will give us a better idea on how to actually approach some of the problems that you're going to encounter. So I'm just going to track any of these is fine. So it gives you an idea of what is entailed inside of Nuke. All right, so for Nuke, you got to pick one of the shots. So we decided, you're going to do either or. You could do one like this, a different camera angle, or this one. It's up to you which one you actually use. Either or is going to be the same approach for both of them. The idea will be, so you dumped out the sequence. If you're going to want to work with the sequence, then you load the sequence and you start working with it. So it doesn't matter which of the two you decide to use, you still have to do the same procedure of transcoding this into an image sequence. All right? So from that process, I'm going to go ahead and keep the syntheyes. We have the traditional track that you did in syntheyes is going to be right there, for example. So we already discussed what happens when you bring something from syntheyes inside of Nuke. Those signature colors on the markers and stuff like that that come in. So now we're going to discuss what happens inside of Nuke if you track straight from Nuke. All right, so it doesn't matter which of the two you pick. Just make sure that it's a different one than you pick from syntheyes or for syntheyes. So let's go ahead and start the tracking process. So this one already has been transcoded into a target sequence. So the next thing that we're going to do is we're going to set our project accordingly to the image settings. So this image is actually 1280 by 720. So we're going to start with that. Okay. Then it's going to be frame 1 through 159 or 151 for this specific footage. So the next thing that we're going to do is we're going to start with rotoscope. The idea behind this is like in syntheyes, we went through and we rotoscoped the character that we didn't want, right? So in this scenario, we're going to do exactly the same thing that we did in syntheyes, and we're going to compare the process of both of them. So we're going to compare what we did in syntheyes and how that equates to what we're going to do inside of Nuke. So you can notice it's going to be the same thing. So the first stage that we did was rotoscoping. So let's go ahead and do the roto very quick. And again, the roto doesn't have to be perfect. It just has to cover the character to the best of your ability, right? So let's go ahead and do a quick roto in here. And we're going to have some issues in this side and that side there. So let's go ahead and just add another point in here. I want to have a point that I'm able to manipulate on that area and on this area. So at least I want a couple points that I'm able to manipulate a little bit more. All right. So now that we have this, we're going to go ahead and animate it over time. I'm going to go to the last frame, and I'm going to scale it down very quick. So let's take that, hold on Shift, scale it down, move it into position, and start from there. So let's go back. I'm going to go right around there, scale it down, put it into position, and move on. All right. So just enough information is getting discarded for us to be able to do our work. So let's go ahead and do our keys where we are on. Right about there. 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 All right. So Nuke is a lot faster for rotoscoping, so it's going to be a lot easier for you guys to do any type of roto work in that scenario, so it should be all right. All right, I'm just going to look for any skip of the arm right there, so that way I'm going to bring this guys just a little bit inward, so it makes it a little bit easier. So what you want to do is you want to kind of allow the automatic tracker to grab as many points as it can. Nuke is fully automated, the majority of it. We do have some tweaks that we could do, but other than that, it's a fully automated system. So yeah, so we're going to try to get as much information as we can into the track. So it's going to be important that at least you have some of that taken care of. All right, so we're good with that. We have enough for the roto. Usually I like to label the roto. So I go to the node and I say character. Okay, this is going to be character A, and we're good. All right, so the next stage is create the track itself. So in syntheyes is a whole self-contained package, right? That is only and exclusively for the purpose of tracking and match moving. Well, in Nuke, syntheyes is only one node. So is the camera tracker node. So essentially, when you create that, the whole software syntheyes is just this node inside of Nuke. Okay? So we're replacing syntheyes for one node, one stage of the whole process. All right, so now that we have that in place, the next thing that we want to do is, there's a couple of ways of controlling or connecting the mask into the system. The first way that people like to do it is this way. I don't like that way. I like to see where things are coming from, and I like to keep the visual language of Nuke flying all the way through my script so you can understand it all the way through. So essentially, when we're compositing, we like to see where things are going. By having this straight on, yes, you understand it and whatever, but it's not kind of suited for a modular approach. So what we try to do is we try to keep things relative or consistent to where they need to go. So essentially, mask input, you have the mask input right there. We're going to keep it on the left-hand side, like an A input in this case. And that automatically is telling me that, hey, we have a mask that we're doing for this. Instead of having it straight through that we might get confused. So it's a lot easier for somebody to see it, and it's a lot easier for us to reuse it multiple times. So now that we have that, the next thing that we have to do is we're going to go into the camera tracker itself. So double click on it, and there's a couple of settings that we need to do before we start the tracking process. The first thing is telling the software what we're trying to track. And in this case, we're trying to track an image sequence instead of image stills. So that's the first thing that we want to do. By the way, I shouldn't zoom in with the OBS. All right, so you have the option to also track stills. That means if you're trying to do any type of photogrammetry where you're trying to model from images by creating a point cloud data, you could use stills from your phone, you could use stills from a camera in order to be able to model an object. So those of you going to go and do a little bit of modeling, Ken will probably guide you through photogrammetry and retopologizing and stuff like that. So there's a couple of techniques that we use in today's industry. So in Nuke, you could do that. It could be your own photogrammetry software. But we're going to be tracking sequences. The next thing that we want to do is the mask input. So the mask is actually establishing the actual mask input that we're using. So we want to use the mask alpha. If by some reason you had the roto inside the stream, if the roto was set up this way, we call that the source. Okay, we call that the source mask. So essentially, if it was in stream, you will use the source section of it. If it's outside the stream on the mask input, you will use the mask section of it. All right, so this is a mask alpha, so I'm going to do that. I'm going to delete the source. I don't need it on the source. All right, and we talked already about why. Now, the next thing that I do is the input range, from where to where I want to track. The cool thing about Nuke is the same as syntheyes, you could establish only how much to track. So you could say, you know what, I'm getting some issues from frame, let's say 20 to frame 75. So I want to focus only on that section, to track only that specific portion, and then combine it with another track that I have. So you could do that. You could establish how much to track, right? In this case, we're going to leave it based on the input. Input will be whatever the source range is. It will use that as the tracking scenario. Now, the next thing that we're going to focus on is the camera. Now, like syntheyes, anytime that we loaded a new footage, it asks you for camera information, right? The film back, it asks you if it was surrounding shutter or not. It asks you what is the aspect ratio, frames per second. So in Nuke, all that is on the camera section of the tracker. I'm going to zoom in again. On OBS, you might see a tearing of the image. It will jump to the corner over here. But that's pretty much the same information that we're going to populate here. All right? Now, so in this case, we're going to switch and we're going to say what type of camera motion do we have. Now, looking at the camera as a handheld movement, right? Nuke will give you a couple of options. From rotation only, that's what we call nodal, that is on a tripod, to linear motion, that means it's moving in a straight line, it's not moving left or right or anything like that. That means like in a dolly system or something like that. And planar motion, that means it's not jumping up and down, it's actually straight. It's moving straight, but it can move left or right, but it's in a plane, in a flat ground scenario, which is a lot easier to constrain it, like X and Z kind of axes. So in this case, because it's moving X, Z, and Y in all the motion, we're going to actually go with free camera. So it's more of a handheld scenario. The other thing is lens distortion. Well, in syntheyes, we have to calculate the lens distortion by turning on that feature, right? In Nuke, you could tell on the lens distortion to make sure that calculated by saying is an unknown lens. I don't have a node that is undistorted. Now, if I was using the syntheyes undistort, I could literally use this guy. By some reason, I did a syntheyes track and I couldn't get it to work, but I got a good lens distortion calculation. I could use this guy to first undistort the footage, and then here I will say no lens distortion whatsoever. Just track for whatever I give you. But the problem is the original footage here is actually distorted, therefore we have to calculate the undistort. Okay? So we're going to say unknown lens, so it calculates the distortion. The other thing that we're going to do is we're going to turn on undistort input. Okay? Like I said, it doesn't like this. So what that's going to do is when we export all the data out, automatically it's going to put a lens distortion node to undistort the plate and remove the lens distortion so we could work with a 3D setup in an undistorted fashion. That's how you want it. And then later on we could apply the redistortion to the CG by exporting another lens distortion with the inverse operation. All right, the next thing is the focal length. We don't know, so unknown. And the last but not least is the film back. And we established that the film back for this shot was 4.6 something for this camera, right? Because of the type of lens and the type of sensor it had, a 1/3 sensor. So either you could leave it the way it is because right now it's set up for HD type of crop ratio, like 16:9, or you could put the numbers in there intact. Now, unlike syntheyes, if you change the first number, it won't change the second number. Okay? In Nuke, you have to know the values of both. So if by some reason you already know the value because you have tracked in syntheyes multiple times the shots and you already have a value that you figured out, you could actually input those values here. It's not considered cheating because that's what we're doing all the time. We actually cheat. That is our job. So it's not considered a bad cheat to actually go to syntheyes, figure out what the thing is, and move it over. We do that all the time with any software. The other thing that you could have is in the presets, if you could find the preset here of this specific camera, then you could use that. Now, here there's no preset for Panasonic, so we don't have a preset for that camera. Now, last but not least, we're done with the data. So what do we do next? We track. So all the steps that you need to do, like syntheyes, they're in a tab system, 1, 2, 3, 4, whatever. In here, they're top to bottom. You first analyze, so you track it, then you solve it, then you fix the error, and you're done. You export the data. So let's go ahead and track. So if you notice, everything is exactly on the same view. So in the outline there, we have everything exactly on the same location. So as we're tracking, everything goes through the same process. Now you could see what the automated tracker is doing is not tracking anything that was inside the roto, so that's good. And it's kind of holding to features on its own, kind of creating new ones where it needs, and nothing else when it doesn't. So you're going to let it go through the track. It goes first forward to check for all the data, and it goes backwards to double check and isolate what is good from what is bad. And usually the first frames, there's no trackers on the right-hand side and stuff like that, so we always have to watch out for that. So now that we have this, you notice that the same as in syntheyes, there's very little trackers on that right-hand side. Sometimes we will have to isolate that and create our own the same way, but we have enough trackers in the middle there to kind of start. So these are all the trackers generated by Nuke, which is great, and we didn't have to tweak anything else. But if by some reason we needed to tweak to get more trackers, inside of Nuke, you got the settings section, and that's where we actually tweak how many features we want. So the settings section in Nuke is the equivalent to when we go in syntheyes to the feature section that we say blip all frames, and then we go to that advanced and start tweaking. This section right here is the equivalent to that, okay? Where we could actually increase the amount of trackers and tweak the detection threshold of the edge detect. So that's how we will detect our features. So if I needed more, I could turn on like a preview so I could see more. The server went down. So I'm going to say if I need 1,000, I could put 1,000 in there. And that's 1,000 features that I could track, you see? And what that will do is it will cover the whole thing for me. Now, it has so many points that the more you put in there doesn't mean that your result will be better, Okay, that's a misconception. The more points you have, that means there's more averaging of the error, but it doesn't give you a better result. All right. We use this for extremely complex type of shots that no matter what, we need to try to figure out something out of it. So we could use this and then combine some of the trackers. All right, so we're going to leave it at 150, the default that we had already, and then go back to the camera track, update the track very quick, and hit OK, just so it goes back into. So yeah, so in the settings section, you could tweak a lot of that information to be able to get a better result. I won't bore you with the details there. There's a couple of podcasts that cover that. All right, so now that we have this, the next stage after we do 2D tracking, this is the 2D tracking stage in Nuke, the equivalent in syntheyes 2D tracks, right, is to actually solve the result to create a 3D camera, what we call camera calibration. So in order for us to do the final solve or the final camera calibration, the next thing that we have to do is just click on the solve button. And that's pretty much it. So when you do that, it will do another calibration pass. It will look at all the points, and it will do the same thing that it did in syntheyes. And this is the equivalent of the solver panel. Go into the solver panel, hit and solve for the first time. All right. So now that we did the solve, you notice that something happened with the lens. It actually went in and undistorted the image. It actually went in and pushed it back out. So that's pretty much how much distortion Nuke calculated based on the motion of that camera. So that's a lot. Okay? So now that we have that and everything is set in stone at that point, we got everything how we want. You notice that the solve give us a couple of trackers that are red, some that are still orange, like this one on the back, for example. They're still orange in color. There's some that are green with a little black X to the next of it. So essentially, those are trackers that green means good. They're actually trackers that got solved. Red means, hell no, these are really bad. And orange means, I didn't even solve them. They're not even recognizable to me. So that's what those three separation means. Now, at the bottom here, it gives you an error. So right now, with the first initial track that we did, we are 0.75 on the error. We want to get it lower, of course. But that's a pretty good start for that. So what we want to do is we want to go now and start tweaking this. What you guys know in syntheyes is the refinement process. Going in, removing error trackers, cleaning up your trackers, deleting trackers by hand. So now we're going to do all that, the same as we did in syntheyes. But for that, we're going to switch our view in the tabs at the top to user tracks, to auto tracks in this case. Now the auto tracks will allow us to see the curve. So we can see all the curves associated with our track, and we can see where they actually jump, right? And we can see the problem areas that our track currently has. Okay? So what we're going to do is we're going to start the tweaking process to try to clean up as much of these information as possible. So for this, what I want to do is there's a little 3 sliders at the bottom that go from minimum length to max error. So what I want to do is I want to start cleaning up the max error. So for that, I'm going to click on max error and hold down my command key and click on error max. So essentially it's going to look something like this. The slider that we're going to be tweaking on is max error. The actual curve that we're going to be tweaking on is error max. These error ones show you the curve. These ones that don't have the error in front of them show you the slider, the actual cut, like the knife that we're going to use to cut the data. All right? So you will notice that at the top here, you see the knife right here. This is the data that we're going to cut. Watch how the threshold, as I reduce this number, starts coming down in the value. These are the frames in the range. This is the value of the error. Okay, so look at that now. So right now we're at 5.33. It shows you the highest error on the script. Uh-oh. Machine froze completely. There we go. So let's go down here, and you can see the knife. So as the knife keeps going down, you notice that something happens on your screen. A lot of those trackers start showing in red. Okay? And what that is telling you is that all those trackers are above the threshold line. So what I want to do is I want to delete reject it. I'm going to hit yes, and then all those trackers just got cut by that threshold. So now, how do you refine inside of Nuke? That button of switching to refine mode. So in this case, inside of Nuke, you have this section at the bottom. And what you're going to do is you're going to turn on the three main setups: focal length, position, and rotation. So if you want to refine those three, now the next thing that you do is after you cut, you click on the refine solve, and we'll go through the process. It will refine it, and that will give you a lower error. So now we're at 0.62 on our error from 0.75. So now the next one is the max track error. So we're going to select that, select the curve. Now we can see our max track error curve and the cutter right there. We're going to lower this to about 1.15 on the error. Hit delete, reject it, hit yes, and now we got a cleaner solution. So let's go ahead and refine the solve. We're good. We're at 0.5, 0.58 in this case. So now we have a more solid scenario. Now I need to remove all these not calculated trackers, so unsolved, all these kind of yellow trackers. So we're going to go ahead and remove that by deleting unsolved trackers and hitting yes, and that pretty much gets rid of all those trackers. All right. So now we have like a little cloud of good trackers. There's one there, delete, reject it, yes. So now we have a cloud of good trackers that follow the scene, and you can see the path. Those are the trails, where the tracker is going from to. All right, so now that we have that, now I can hit tab on my screen very quick. Zoom out. Let's hit tab. Okay, let me switch keyboards very quick. That keyboard is kind of screwed up. So now I can see an actual 360-degree kind of view, a full 3D view of the environment. So I can notice very quick where is the actual bridge. So you can see the structure right there, right? You can see where the foreground element is. You can see where the bridge is at. Even you can see the trackers. You can see those reds right there. Boom, boom, boom. So as I zoom back, you notice the structure is right there. But the problem is everything is slanted. If you notice sideways, everything is going downwards. Because the camera right now is set up right in the center of the world, looking forward, so everything looks like it's downward. So the next step is, like in syntheyes, after you have cleaned it up and you get a nice, good result, the next step is to export. This thing just... whatever. All right, so the next thing will be to export. So what we're trying to do is we're trying to go now down here, and after we follow all the steps, we go to the export section. So as syntheyes, the same as a syntheyes, we go in and we want to export like a full rig. So that means we want to export the camera, the scene, the models, everything else that we have from there. So we're going to go to the scene setup. So Scene Plus is the one that we're going to be using for this. Okay. And then we're going to hit create. Now as soon as you do that, you're going to get this setup that got outputted from that structure there. So it's similar to what gets outputted out of syntheyes, but in syntheyes you're seeing these little guys right here, right? Those are the ST maps. In Nuke you don't see the ST maps, you see the lens distortion right there, okay? Until we tell it to output an ST or something like that. But in this case we have the lens distortion. What that is doing for us is just undistorting the plate. So the lens distortion is what got calculated. Now we have the option of using that now to do whatever we want. So what I like to do is I like to rename that, and I like to put a big UD for that. So that's the lens distortion calculation. I'm going to put it, I could say 60 for now, so I could see it actually. Just put 20. So at least you guys could see it from there, and then bold. So that's the undistortion process of the lens. So it's undistorting the lens, so that way we could actually work inside of the 3D system correctly, undistorted, fully undistorted. So this is the equivalent of having an image plane inside of Maya and working with an undistorted image plane so all the 3D is correct. All right, so now that we have that, we also have a point cloud data that is provided for you as soon as you export it out. And in order for you to check if the job is done correctly, you go ahead and you hit play. And what you want to do is check to make sure that that point cloud data always stays with the software, with the footage, and it doesn't jump or jitter as you're actually moving. So you got to give it a chance to first cache the whole footage, and then you check it. Don't check it while it's caching because it's always going to lag behind. So the footage always lags behind. There we go. There's no jumps, there's no sliding. Nuke does a pretty good job with tracking, really good. And at least for compositors, this is match moving for compositors, not for match moving artists. For us, is whatever gets the job done quicker. As a compositor, we don't have too much time, so we have to do whatever it takes to do the job. So in this case, Nuke did really good for our job that we need to accomplish in this shot. So now that we know that, we're pretty good with this one. Let's go ahead and move forward. So now that I'm good with this, now I can start labeling stuff correctly for what I needed to do. So I'm going to disable the points right now, for example. I need to set up my coordinate systems and stuff like that now. So I'm just going to name this track cam. I'm going to make it green to know that it's good. And now I'm going to start rotating the world and everything else that is associated with it. So in order to do that, in order to rotate the world, right now the scene is linked to the original tracker. So remember, the exported scene here is actually linked to, for example, syntheyes. So any changes that I make in syntheyes, I don't have to re-export anything. Automatically, any change that I make to the track will get transferred to my other elements in there. That's why you see this little green line. Those are expressions. I hide them by using Option E, so I don't see them, but I see the little link there. So this is what we're going to do. So now I'm going to go back to the camera tracker, and now we're going to set up our coordinate system, the lineup of the whole scene, to make sure that it's correct. So on my camera tracker, I'm going to go ahead and hit Tab and look at my scene in that scenario. Double click on the camera tracker to load it, so that way I can see the point cloud data. And what I want to do is I want to make sure that I select the area that is the ground and make sure that that is flat on the ground itself. Okay? So for that, looking through the camera tracker, not through the scene at the bottom, okay? Looking through the camera tracker node, we're going to go ahead and go forward and find what we want to be the ground plane. So we're going to click on a couple points there. I'm going to click on one, hit Tab, and we will see a little yellow dot. That's that yellow dot right there. Right around in that area there. So if I go sideways, there's that yellow dot. We're looking for that to make sure that that is our origin, for example. So I'm going to hit Tab. I'm going to right click, ground plane, set origin. And that's how we actually assign the coordinate system. So right clicking, setting to origin. So now, as soon as that is set up, if I hit Tab, the whole world moved and set up that point as my origin. Now, the world's still slanted. So now our next job is to establish X or Z or a ground plane. Okay, like same that we did in Maya. In syntheyes. So I'm going to hit Tab again. Actually, this is easier for you guys to see if I split it horizontally. Create a new viewer. Move that viewer over. And hit Tab over here so you guys can see what is going to happen to this guy. All right, so now working through the camera tracker, let's move the viewer to the side here. I'm going to select other points other than the one that I just set up as a ground plane. So I'm going to select, say, that point on the side, maybe that point on the back, maybe this point on the front. So I can cross at that point. All right. So what I'm looking for is that all those points are coplanar to each other. Okay, and they are. So if I look at it sideways, those are all the points running through that plane right there. So what coplanar means is that, mostly for the online students, if you haven't had this class before, what coplanar means is that all the points that I selected, if we have a plane, right, let's say we have a straight plane, the points that I selected will be actually crossing as close as possible through that plane. Okay? That way when we establish the ground, they will be as close as possible to the ground. Now, the problem is that this ground at the bottom here is not straight. It actually is bumpy. So it has this, right? Because it's sand. So it's not actually a floor, like a tile floor, concrete that is polished. So one of the things to think about is when you're thinking about establishing the ground plane, you're going to think about an average. So that means you're going to have trackers that are up here, down here, maybe in the middle, maybe all the way to the peaks of what you're selecting. So what is going to happen is that the actual ground plane that we create is going to average, and it's going to cross in between the average of all of those, not exactly through the points. Okay? So that's one thing you got to realize. If not, you're going to struggle trying to put that exactly where the points go, and it's not going to happen. It's just an average. All right? So now that we know that, let's hit Tab over here, and let's delete this guy right here, and double click on this guy. Now, if you notice, anytime I double click, when this is active, I'm able to see it. If this is not active, I don't see anything, even if I'm connecting to the object. Okay? The settings have to be loaded for you to be able to see anything that is happening. So double click, as soon as it's loaded, you see everything that you need to work with in the view and in the 3D. All right, so let's go ahead and select those points. So we said that one was good. We said that one. Trying to find stuff that is coplanar to one another. If by some reason you select something that is out of whack, you're going to see it. But right now, it's pretty good. They're all going through the plane. Let's do that. What you want to be aware of is don't select the one that you use as an origin, like I just did. All right? So there you go. So the next thing that we're going to do is after you select them, you right-click on one of them, go ground plane again, and set to select it. And what it's going to do is going to take all those and it's going to change the scene. So boop. So now the whole scene got changed, and now you got these little kind of purple, magenta type of color markers, kind of angling the whole scene, and that's going to be your anchors to make sure that everything is going through the ground plane. So now if we look at it, there's our ground plane. Okay, everything is going through it, and now we have our scene. The next thing that I like to do is I like to rotate everything so the camera is always facing away to C. So Z should be always forward. And right now, by default, the scene is not set up that way. We're looking in X. So X right now is our away from the camera. We don't want that, so we want to rotate it a little bit. So again, you can select any of these points and set it to be Z or Z. But what we're going to do is I'm going to show you how to move it manually, like in syntheyes. So in order to move something manually here and set up distance constraints, scale constraints, we're going to go to the output window and the scene windows. Those two will be used to actually control the output and the scene itself, how everything works. So the most of the changes we will do it on the scene because everything is linked from the scene to the output. So therefore, if you see these blues here, you don't want to touch it at that stage. So we want to go into the scene so it controls that output for us. So in order to do this, there's a couple of things that I'm missing. One, look at the scale of the scene. It's tiny. And one of those blue grid units is actually 1 centimeter. And this is smaller than 1 centimeter. So if we decide to send this to Maya to do modeling or whatever, we're going to have a hard time because Maya has far clipping planes and near clipping planes. So if you try to model in a less than 1 centimeter unit, it's going to clip every time. It's not going to let you see what is close to you. So a lot of people always have that issue and they see like the camera cuts their model. It's because they're modeling tinier than 1 centimeter. So we want to make sure that we have at least some scale. So for that, let's start by setting up the distance constraint, in this case, the scale of the scene. It's the same as in syntheyes. You pick one, pick the other. So the same idea here. What I'm going to do is I'm going to pick 2 of these trackers, 1 and 2, right? And I'm going to look at them to see if they're in an area that I want to establish as a constraint. So I want the distance from that tracker to that tracker to be 1 centimeter in this case. If you actually measure it on set, you want whatever the set says. So if it's 1 foot, 1 foot, and so on and so forth. So what I'm going to do is I'm going to right click after I select those 2, go to scene, at distance scale, or scale distance. Boom. You're going to see the same thing that you saw in syntheyes. And you're going to see in the scene tab, you're going to see this guy right here. And this is to establish the distance constraint. Where do you see this in syntheyes? On the constraint window, the constraint tab. You see the same thing. So I'm going to set that to 1. And watch what happens with the whole scene on the other side. Let's zoom out a little bit. Boom. Now everything got scaled, and now one of these is one of those units big. So now everything is bigger than the center of the grid. Okay? As we're doing this, it already is solved. So we just don't need to resolve anything when we're doing this. In syntheyes, you have to refine it when you do this. Okay? In this Nuke, you don't have to do that. So now that we have our scale, let's go ahead and set up what is the z-axis. I want the z-axis to go that way. Right now it's sideways. So what we're going to do is, in the same scene setup, we're going to go into the rotation and start rotating our object. So we want it to face away on Z. So Z has to be positive at that stage. So what we're going to do is we're going to rotate it. It's about 90 degrees in this case. Okay. Away from the scene. Now this is the same place that when we start putting geometry, we want to line it up or anything like that. Here is where we could actually go in and do that and line it up and get it all nice and working. So now we have everything on Z. Now it's time to save. This is 1806. And save. All right. So now we're done with that. And our scene is completely set up for the purpose of working. So I have my lens distortion. The other thing that I'm going to export now out of this is my redistort. I need a redistort because essentially I want to redistort all the CG to match the original live action. So the redistort is as easy as taking this guy and inverting it, but in order to make sure that we're correct, we're going to go back to the camera tracker, and in the camera tracker, in the export setup, we could go ahead and select the redistort option. So we're going to go back here, we're going to look for distortion, we're going to hit create, and you're going to create a new one out of this. All right? So the difference between these two is this. So when we look at it, one has the undistort turn off, and the other one has the undistort turn on. That's it. So the one that you use to undistort the data, okay, will have it on. The one that you use to redistort the data will have it off. Essentially, it's just inverting the information. Okay? So that's what the difference between these two guys are. So if you already know that, then you could duplicate this, and you know how it works internally. Turn that one off, go to the notes, and put RD for redistortion. This is the one that is going to be used down here. So if we do anything that is 3D, that will go with the footage from Nuke, that's the one that is going to redistort it so you actually can put it over the original plate. All right, so anything that we do there, the next step will be you comp all that over the original. Okay? And that will go over in that scenario. So that means everything will get redistorted to the original plate. Does that make sense? So that's how the Nuke setup works. Now, for modeling, what we said before was to go in and use the model builder for this scenario. Now, model builder doesn't like to use the two view setup all the time, so I'm going to go ahead and delete the two of them very quickly, clean up one of the sides. Let's close the pane here and then create a new one by selecting something and hitting 1. All right. So now that we have the scene clean, let's go ahead and model it. So like I showed you before using the model builder here, we're going to use the same technique over here. So now that we have the camera, I'm going to duplicate the camera for the purpose of cleanness. So the camera will always be linked at this point still to the original camera tracker. So if we make any changes, I tell you, hey, you still need to tweak this here and there, it will still transfer the information. Then we need the undistorted scenario because we're going to model from an undistorted plate. You always should do this even in Maya. And then we're going to use the footage as well. Now I like to use a postage stamp if I'm doing side to side, but again, this is for the purpose of demonstration. So I like to use postage stamp. Let's delete this guy from here. That guy will go there. That way you can see where everything is coming from. That way I don't have to load the same footage twice. If not, I'm loading the same footage twice. All right, so let's go through the lens distortion. So it undistorts the plate. Now we're ready for modeling. So we put the model builder here, and we connect it to the source. The source, there's 4 inputs. Source will be the footage. Camera will be the track camera. Texture will be any texture that you want to use in order to be able to colorize your geo. And then geo will be used if you actually have a model geo that actually adjusts to this specific scenario to do like a survey, like a projection setup in there for the geometry to be able to build upon that. So that will go connected there. So that means for now, these two, the texture and the geo, are not used. Okay, we're going to keep it empty. So you only have to focus on the source and the camera. If your track is solid, this process will be painless. If your track is not solid and there's still jitters and all these other things, this will be a nightmare shot at that point. So it's up to you. If your track is good, you won't have any problems. If your track is bad, you're going to have a lot of problems. Because nothing will match. And you will try to massage the geometry back into place, and it will be good in a couple frames, then off in others, and so on and so forth. So you're going to end up with a lot of issues. All right, so now that you have the model builder, it's one of the easiest things to use. One of the best things that actually the people at Foundry brought to the table with this guy. A lot of people don't like it. I love it. We use it all the time. So, and they don't like it because probably they don't understand it. And it's easy to hate something that you don't understand, right? So essentially what we're going to do is, the other thing that I like to use this model builder for is lineup, scene lineup. In syntheyes, you're able to see the perspective view. So you're able to line it up really easy. But here you have to kind of guess a little bit. So by using a model builder here, I can line up the scene even better. So if I notice, oh, the horizon is too high, even though I lined it up, I would like to manually go in and tweak it. So I could go back to the camera track, and the beauty of having everything linked still through the expressions is that I could go in and say, you know what, I want to rotate that on X just a little bit, just to get it, shifted a little bit there, and then on the Z-axis, just a little bit, shift it a little bit there, right, to kind of get it back into the horizon that I need. All right, and doing that, I could literally see it using the model builder node. It's like a cheat that you can use in order to facilitate your placing of elements. And that was painless because everything that I did automatically transferred. So this is like working with Houdini. It's a procedural approach to what you're doing. That means no matter what you do, you're still at the top of that stream. You could change anything and it will go through the stream. Syntheyes, you have to refine it every time that you do this. That's the difference there. There's something called faces, but it's way too advanced right now for the majority of you guys. But if you would like to research faces, it's similar to this. It's a node-based approach. All right, so now that we have this, we have our shot. So now you're ready to actually model. Now, if you would like to get rid of all those point clouds, just close the settings and double-click on the model builder to be able to work. Now, model builder, we could work in full screen mode. It's super easy to use. It's straightforward. So on the left-hand side, you got your modeling tools, your alignment tools, and your editing tools. So at the top, you will have your modeling tools, and you can model any type of primitive, and you could use points as surveys. So for example, if you need to do a zero-weighted tracker, you could use one of these points, for example. And you want to know exactly where something is without doing the whole model, you could actually place the point where you want it. We could zoom in while we're working with that, and I could say, oh, I want this one to be right on this corner. And I'm going to move a couple frames. It's going to offset. The only thing I have to do is move it back to that point. And by default, Nuke will constrain it for you. So if you notice, there's a line there. And that's what we call the align mode. That's the second mode that you got in here. And Nuke will constrain it to one axis of motion because Nuke is using the camera to kind of place it where it's going to be, and then as you set up keyframes, it will stick to that path, and it will help you line it up a little bit easier. So now what I did there was create a zero-weighted tracker. So if we don't want, let's say, if I only want to place an explosion in that location, I don't need to create geometry for that, right? I could put a locator for the modelers to know, or the Houdini artist to know, hey, the explosion goes here. So right there, I did that, and I say, okay, my explosion is going to go there. A missile is going to hit that portion, it's going to hit that area, it's going to crash. I put a locator in there. Now, if I look at the 3D aspect of it, there's my locator in 3D space. So right about there, we already generated what we needed for the Maya guys, and we don't need the whole model. We just have that, right? So that gives you an idea. And working with the model builder, the only way to get back to the model builder, just click on the camera again and done. You want to get out of the model builder, turn off the camera, and you're out of it. So if you want to model from the side view as you're working, whatever, then you go back and you go back into it. It's super easy to transition from one to the other. All right, so now that we have that, that point stays there. No matter what I do, it will stay there, and you can readjust it little by little as you go through the initial and the last stages. Like right here is very offset. That tells me that I still need to tweak the track, okay? If you see it that far off. But if you move it, you will see that it will constrain. So now I got to check if it's the track or it's only a matter of that. So it was just a matter of moving the point to find the exact location of that area. So there we go. So we're good. So we don't have to fix the track at that point. All of a sudden, we realized, oh, no, it was just that the point was still a couple pixels off because we tweaked it at the beginning where it was further away. So as we got close, we realized, oh, we have to be a little bit closer. So you move it, and if it stays, you're good. That doesn't animate. Contrary to popular belief, that is not animating the geometry or the points. When you place it, it's just finding its location in 3D space. So it's not animating it. Even though it's creating keyframes, it's not moving it. It will stay where you place it. All right? It's just averaging. It's just triangulating. All right. So now that we have that, the next stage will be, okay, let's model something. So what I want to do is, let's go ahead and, let's say I tell you this is the area where we're going to have the majority of the destruction. We already saw how to model like a quick column and stuff like that. You could extrude that out. But let's say I want something here. So I want to use like one of these bricks as my base to start modeling. So what I'm going to do is I'm going to pick what I want out of the top. I'm going to pick a card. It's the easiest to model with, right? And what I'm going to do is I'm going to go ahead and click and drag to see where I want to place this. So the next thing that I do is I'm going to zoom in. I'm going to kind of contrast this a little bit so you guys can see it a little bit better. And if you notice, that's a corner, that's another corner, that's another corner, that's another corner. So you can find whatever you like in order to follow. So what I'm going to do is I'm going to move some of these corners. Oh, forgot that this one is so screwed up. So I'm going to move one of these corners to the corner that I want down here, one to the corner that I want down here, another one to the corner there, another one to the corner there. All right? And then you tweak it to whatever your needs are on that stage. Okay. So now that you have done your initial tweak, you move a couple frames and see where it's going to be, and then try to move it back into position. Okay. Anything that you need to tweak, you will tweak it here, then move it again, get it a little bit of a closer frame, something that is a little bit closer there, and try to move it back into position again. Now, if by some reason it's slanted, you will be able to see it, so you might have to move 1 point or 2 points away from each other in order to get that to behave correctly. So you go back and forth, go to another frame, see if you can get it. Look like it's staying there pretty good. Now, I like to evaluate it sometimes because sometimes it looks straight, but it might be all slanted. So sometimes you have to go in and kind of adjust it that way. So I'm going to go back like that and see if it's actually slanted forward. If it's slanted forward, I know we're too far, right? That means I didn't ever got it perfect. So at this stage, you could actually go in. And if you notice it's slanted when it should be straight, you could look at your point cloud data, or you could go to the edit mode. And in the edit mode, you could go in, right click on top of the object, and you can select the faces or the object itself to be able to manipulate it. So let's go back to object selection. Let's select the object. You will get the traditional gimbals that you get anywhere else. So I know that's straight, and I want it straight. So I'm going to go ahead and hold down the Command and Shift. Command for rotating, Shift will be for scaling and stuff like that. So now it's straight. So now I can look back through my camera. I could see if it's actually good or not, and now we could go in and say, oh, okay, we need to tweak now anything else that we're going to do. So let's go ahead and kind of extrude some of these edges. So the first thing I want to do is I want to move it across and see if it actually stays within the same location. Right? So if I have it here, now I can move it up, I can move it sideways, left or right, and let's go ahead and scale it up very quick. You could extrude it or you could scale it, it's up to you. Alright, and using Command and Shift for the scale tool. Alright, now if it's a little bit slanted there's two things. So you could rotate it this way and that way. My Wacom is a little bit weak at this point. Or you could rotate it up and down like that. It's up to you. Alright, so the next thing is you could also edit the vertices. So you could say, okay, vertex selection, let's pick that vertex and let's take it all the way down here if that's what you want to do, or you could extrude. The same idea as before. So let's go ahead and just do some quick extrudes. So let's take edge selection, and let's select the edge that we want to extrude. Let's say I want to extrude all these, doesn't matter. We're going to hit enter, extrude it down, right about there. Enter again, extrude it down, enter again, extrude it down. Just reset this back very quick. Alright, so I'm just going to go ahead and make sure that everything is extruded the way that I need it. Now, the next thing will be, okay, we could actually take these and start modeling with them and stuff like that. Now, you'll be like, oh, I want to create this over here, but I don't want to just do one at a time, you know, all that mumbo jumbo that we have to do, right? So you might want to do a little bit like this. It's all right. We could do a little bit better than that. So let's say you decide, yeah, you don't want to do that much work. So there's a tool here that you could actually use called the carving tool. So if we click on the carve tool, we could actually click on what we see, and we could carve away our shape, right? So on that side, I don't see it, so I'm going to hit enter very quick to commit it. I'm going to go to a plane where I could actually see it, and then let's move this guy down right there, and let's continue the carving. So essentially, from a shape, you could actually go in and create a quick setup for you to be able to work on it. And by the way, you can move it anywhere that you want. So that means as I'm working, I can move it up, I can move it down, no matter what. So essentially, if you look at it, it's not so hard to actually go in and model using the model builder. I haven't done anything here that is not basic. So when you realize it's like, whoa, it's really basic. And yeah, there's not a lot of issues or anything like that. So let's go ahead and do a carve here. I'm going to break one of the cardinal rules. I'm going to do this, go there, and go there. Whoops. Doesn't like it. I guess because I'm breaking the rules, like always. All right. Usually you could throw a line all the way from the top to the bottom, but it doesn't like it, it doesn't like it. All right, so I'm going to take this, move it up like that. It's fine. You get the point, right? So you could go ahead and model it, angle it, whatever you want to do. Now, the other thing that we could do now is like say, okay, I need to create that tunnel. So I'm going to select the faces. So I'm going to select the faces over here, right? Anything that is inside the tunnel. I have two options. One, I could use them to do the job that I need to, right? So I could go back and say, okay, let's hit enter on that. And you're like, how am I going to extrude it? Well, click outside of this. I hit enter already. So I'm going to be able to, I hit F to kind of rotate around there. I'm going to do that. Okay? I'm going to go back, lock it. And then we're going to go in and out like that. So that's telling me that I still haven't lined up properly the angle of my world. All right, so now that we have that, there we go. So we have that essentially there. We can see one side we didn't pay too much attention to. But now that I have that, I have a very basic, rudimentary type of environment now going. Now that side, on the right-hand side, I need to line that up. And like I said, don't judge it until you finish caching it, because always the footage will be behind the model or the 3D. So wait until it caches, and then you will judge your motion. Make sure that everything is good. I notice right there that I need to angle everything perfect, a little bit better. Make sure that my world is good. So for that, I will use the little markers to know where things are at. So instead of using the model, I will marker first. I will put the markers to know exactly where things go, and then I will model based on those markers. So it will be a lot easier that way. All right, keep going, keep going, keep going, keep going, keep going. All right, so it's cached now. So now we see it against that. If it sticks, we're good. You see it's angled because notice the right-hand side. If you notice that right-hand side, look how it slides faster in front of us. So right there, we know that our angle is like too much this way, right? So this side right here is actually further closer to us than this side over here. So now you know, okay, I need to rotate this. I'm not using the point cloud data, so all that will help you immensely to actually do the job a little bit better. But that's pretty much an idea of how to actually approach that problem. All right, so I'm going to go back to this guy, and let's click on this. Let's rotate around. All right. Now I want to see the point cloud data to see how far I am from the original one. So I'm going to put 2 in here. And there it is. That's why this looks like it's a lot closer. So what we could do is we could go back. Let's go to object selection. And we could go in and we can rotate the object that we want to move. So essentially anything else that we want to do with it, we can. So let's go object selection, click on the object, and then we can rotate the object there, move it back, space it off object axes, kind of line it up a little bit more with By the way, I'm on the top view. I hit C on my keyboard, and I can line it up a little bit more with my environment there. Okay. All right, so let's go through the model builder very quick. Select a camera track, click on it. All right. So little by little, now we can get it a little bit more lined up. So now we can model based on that, because all this we modeled before the way that we had it. So now we could go back and line up that whole side again. All right, so that's pretty much how we actually go about doing that. After you get that whole model, you can project, you can do anything else that you want to it. There's a lot of different variations that you could do in order to get it to look correct. Okay. So as we go through, you start judging it. Now the last thing I like to do is I like to look at the camera and kind of project the geometry there. So I'm going to bake the geometry very quick so I can see if I could use a projection out of it. And I'm going to create a projection on that specific frame. So projection. And I'm going to bake that. You don't have to do this step. It's just to show you that you could do map paintings or anything like that pretty quickly with this setup. So I'm going to connect the geo here. Now when I look at it in 3D, there's my 3D world. So now I could go ahead and do anything else that I want with it. So if I go back here, yeah, that will work. So this part, again, you don't have to do. It's just for me to test a couple of things. So let's put, I'm going to put a scan line very quick to see if it actually renders from where I need it. So essentially that's the projection. So if I go back, it will be there. And as I move, I'll be able to get, anything that I need. All right. So now that that is set up, let's go ahead and do a quick map painting on it. So I'm just going to do a rotor paint. And I decide, okay, that rotor paint, I'm going to go ahead and take this guy right here. I'm going to hit 1. And I'm going to take frame 33. That's where we're painting. Let's put 33 here. So let's say my job was to remove all these tracking markers, right? So I'm going to remove some of them here. So I'm going to go in and say, okay, let's go in and clone them. So I'm going to go from there, I'm going to clone there, from there, I'm going to clone there, from there, there, and so on and so forth. So let's say we started doing those markers and we went through the process of removing the markers, right? So you could do the same thing from every area. So let's say we did those, right? And that was our job, to remove those markers. And then we also went ahead and did, let's say, something like that. All right. So now that we have all those, usually what I like to do is I like to frame hold that. Same frame. And let's go ahead and pre-multiply that very quick. So I'm going to output from these guys. Let's output an alpha very quick. So now I have an output from here where I could just pre-mult these guys, and I have the elements that I use to paint. So now what I'm going to do is I'm going to merge that over very quick as a cleanup, right? And there's my whatever it is with the cleanup. The next thing I'm going to do is I'm going to do a little roto to only isolate some areas, other areas that I want. So let's say I want to only isolate half of this section, or a section here where I didn't want buildings or anything like that. So you could do a roto very quick just to isolate a section of it. So I'm going to go ahead and take that, and let's say I want this section right here. And let's take up to, whoops. So say any other paint that I'm doing on that angle, I could just isolate that area, paint there only, and we should be good to go. So let's put a mask in here, boom, mask it out, and we could be good to go. All right. So now we have that area masked. Let's blur it a little bit to get the edge kind of fall off. And let's move on. So now that I have that, this is my projection. Go back, hit play, and that's essentially what I just projected, right? So now if I use that now, and I take my original footage, the first thing that I have to do is, if by some reason this was what you have to do, we'll go ahead and take this redistort right here, right? And that's what we will have to do. We'll redistort it. Let's go ahead and connect these two here. So now it goes into my comp. So if I go ahead and connect this redistort, we're applying the original lens distortion back into the image. So that's before and after. Okay. And now we're putting it against the footage. And that's what we get from the footage. Now you need to check if there's any type of alpha. If there is, you need to pre-molt. If not, you need to unpremult and then pre-molt. So there's my alpha. Now what we could do is we just hit play, and now we could see the information coming through. Now there's an exposure shift. So as we're getting closer, it's getting darker because of vignetting. So you will start seeing the marks. That's an exposure shift that you also have to animate. If you're a compositor, you have to animate how the camera exposes differently as you're moving. That's why we're not requiring that from you guys right now, but that gives you an idea of where your job will be useful in this stage. So essentially, there it is. So we can put graffiti, we can put whatever the heck we want, new stuff in the shot. But by having a model there, you're able to do that job, right? By having a model there, you're able to do anything else that you want. So, so that kind of gives you an idea very quickly on where this scenario will be useful for you if you decide to do composite. If not, that's where matte painting actually comes from, right? We will use that all the time, and then that's how it works. So that's the same technique I will utilize over and over and over again in different scenarios. So everybody got an idea on how that works? You guys got an idea? Yes? No? Maybe? All right. The what? It doesn't matter. Whatever gets the job done quicker for me. So Nuke does it the majority of the time, Nuke does pretty well. There's some shots that it will never do, like object tracking and stuff like that. Nuke can do object track, but it's not as powerful as syntheyes at that point. Yeah. No, it still has to go into Maya because if our job, I needed to send what I just did in Nuke for the 3D artist to use, then I'll have to send them from Nuke, the export out environment. So essentially stuff like this you could do all the time, like quickly. So if you're able to actually set up a 3D projection setup, you could do stuff like that very fast. So if you have a model in Maya, you could do that quickly with your scenarios. So let me go into a setup and see. So it's important to track just for the purpose of being able to do your job. So those of you who are going to be compositors, matte painting we call it DMP, digital matte painting, but matte painting is traditional, how we call it, but in reality it's photo manipulation, footage manipulation. You will need to understand cameras and use your cameras in order to get the job done. Can't remember if this was so set up. No, it wasn't. Yes, but whatever. I'm trying to remember if it was set up for you guys or not. I think maybe not. All right. So let's open that one as well. All right, so that should be it for the Nuke tracking setup. It's not that hard at first. It takes a little bit of time, but let's take a look. Let me copy something here very quick. Let's put it over here. And hit enter. Let's move it back. Let's see if this loads. Yeah, we'll have to check with you guys later. But yeah, so we'll check later. But essentially, that's pretty much the basis of how to use Nuke's tracking and why we'll use Nuke in a normal traditional track scenario. So we'll first track the setup, then we'll go ahead and export data that we need out of it. We'll model from that, then we'll do our job that we need to do, then we'll comp it against the original, and then we output it to whoever goes next. That will be it.